afternoon. I'm glad to be here, and I'm glad to present our experience in the deployment of the IPv6 in our network. My name is Viktor Frolov. I'm architect Bouygues Telecom in the laboratory department. And more than 13 years I work for the deployment and popularization of IPv6. Bouygues Telecom is second fixed mobile operator in France. Historically, it was just a mobile operator. It portrays the fixed network, and currently we have the auditoria more than 5 millions of fixed subscribers. It's mean 4 millions FTTH and 1 million of DSL subscribers, and 27 millions of mobile subscribers. More than 99% covered for 4G, and currently we are during of 5G deployment. Also, of course, we support 2G, 3G. About IPv6, I would like to concentrate on IPv6 deployment because it's a primary subject. But of course, there is more corresponding with IPv4 deployment. Currently, we have it's a graph for beginning of this year, and the end of the 2025, we have 99% of the IPv6 deployment for the mobile subscribers. It means 99% of subscribers have dual stack on his mobile equipment. All information provided by ARCEP, the French regulator, and this is URL. You can get the report, annual report, where more information about fixed mobile deployment, rate of deployment of IPv6 on the DNS subsystem, on the servers, mail servers, and so on. We have 99%, and here we are on the first place because we began support for the mobile platforms user equipment beginning 2018 for the Android and iPhones. It's two primary platforms. Of course, there is a small amount of the specific platforms normally for the fixed access via mobile network. I don't think the Bouygues Telecom has a specific architecture. It's globally it's the same for all operators, but during the last 15 years, we aggregate the primary part of the network on the backbone level and on the aggregation network level. It means before we had the different aggregation networks for the fixed infrastructure and for mobile infrastructure. Currently, it's merged together. If look the path of the flows, IPv6 in the access and aggregation network is the same. It's just IP, MPLS networks, level 2 VPNs, and flows are commutated until the backbone. And here we have the difference. Fixed flows terminated, tunnels terminated on BNG, broadband gateways, which produce subscriber management service with authentication and gathering the profile from the OSS radio servers. and from BNG it could be routed directly to the internet or to another platform of service. For the mobile, it should route it to the nearest mobile core network data center, POP, point of presence, where it's terminated with all authentication, assignment of the IP address, and after it could be routed back to the backbone to the internet. It's a primary difference, but very important from the point of view of the IPv6 deployment. For each subscriber, we have a different size of delegated prefix. For the fixed subscriber, we have a reservation allocation of /60, which use it for different part of the network. The first /64 use it for the local area network behind the CPE at subscriber. Normally, all equipment in this network provisioned by router solicitation, router advertisement. But for some subscribers who use the router, his own proper router behind a firewall, we produce another possibility to get the IP address. It's DHCP v6. And for that, we have the second /64 subnet in this delegated prefix. And last subnet used for the one part between the CPE and provider networks. But for the mobile subscriber, we allocate just only one 64 subnet. Because for 99.99% of the subscribers, the equipment which use IPv6, it's just their smartphone. Just some users share this connection for the equipment notebook behind, where we have the solution normally for the enterprise clients with connection of the local area network through the mobile access. But this is specific case. Normally, and the primary difference, the delegated prefix for the fixed client, it's communicated the same prefix every time. It's statically related with the client. But for the mobile subscriber, you have the random first subnet available in the pool every time then you connect. If you switch off or go to avion mode and reconnect, you get another address. Because for 99% of the subscribers for smartphone, it's used only for smartphone, it's not important. Because you have no the equipment which should be connected through your mobile access. If take the process of provisioning, equipment make the attach request routed to the mobile core on the control plan, MME, which make authentication at HSS, get the APN corresponding for this client. Access point and talk, and plus PDP type, which explain for the system which virtual APN should be used. Because following the commercial offer, it's just v4 or v6 only, or dual stack. This information and also the tracing area code, resolve it to take the SP gateway. Normally it's two functions aggregated to the same equipment. And the SP gateway, it's equipment which handle the user plan, where configured for each APN, where is the pool IPv6, and following the information communicated by MME, SP gateway in the scope of corresponding APN take the first available /64 and communicate this information back to MME and MME back to the user equipment. No, it's all information communicated inside of the NAS tunnel, no RSRR, no DHCP VCs not needed. Equipment configured could use IPv6 address to communicate through the SP gateway back to the backbone, to GRT table in internet, or to the specific VRF. It depends on the configuration for each APN. For the public clients, it's easy. Normally, we go to the internet and subscriber could communicate. For enterprise client, we have two subtypes. Primary enterprise client use the same behavior like the public client, but for some enterprise clients which needed to have the same delegated prefix every time, we use just small, the same architecture, but with small change. SP gateway could communicate with radio server, and take the specific /64 subnet corresponding for that subscriber. It means every time then subscriber reconnect, he will get the same 64 subnet. But there's two different solutions, and there is a big difference for the, if compare with fixed subscriber. Because for fixed subscriber, it's very important. He takes the same delegated prefix every time. It's important for the internal network, for the using of Internet of Things, for access from the outside. Because automatic configuration of the firewall on CPE, it's complicated. For the public, user equipment get the nearest POP data center, mobile data center, and get the IP address in the pool configured there. And from the internet routing point of view, the flows should be routed from this geographical area to the nearest point of exit, the peering point, and so on. If SP gateway or the whole site is down, user equipment will use another POP, in another region, another geographical area. It means he cannot take the same, the address in the same pool. And of course, he does not take the same delegated prefix, because the pool configured for the same APN, it's configured different pool in each area. It's not possible to have the same pool in two different areas, because it's a behavior, the problem for the routing, ambiguous routing. For the 99% of the clients, it's no problem. Okay, I have the IP address A, I could communicate to internet. I have another address, I could communicate. It's no problem for me. But for the enterprise clients, it's probably not acceptable. That's why for the enterprise clients, we have another solution with redundancy on the core mobile level. For example, it's a 2 SP gateway aggregated to the cluster, and with the same pool, with using of SRP protocol, which synchronize the loopbacks, the pools, the sessions, and if primary SP gateway is down, it's automatically switched to another SP gateway. It's transparent for the subscriber. He keep the same data center, the same pool, and the same delegated prefix. But the price, the amount of equipment need to double it, because it's a question about equipment, license, capacity. It's expensive. That's why it's solution acceptable for the small amount of the enterprise clients, but not for the public clients. Today, it's just this Sunday traffic, IPv6, except at 30% the IPv4 traffic. I'm talking about the mobile traffic. It's mean this year the revolution is past. IPv6 traffic depassed IPv4 traffic. We are in the era of IPv6. What the next? Okay, avec, with 99%, we could say we arrived, deploy dual stack for each subscriber. Okay, we are IPv6 ready, we are the IPv6 dual stack, but it's a primary goal for primary target for each internet service provider. Allow to the subscriber communicate. Why, for what how it he use IPv6? It's not the primary target. And of course, it's we're talking about overlay, but underlay, we're always on the IPv4. All communication between the all network equipment, node B, BTS, base C, RNC, and for the all equipment in the POP data center, communication always on IPv4. It's a problem. For example, Bouygues Telecom, to reduce the cost of the mobile network, share in the country mobile network with another operator, SFR. It's mean France divided on some regions controlled by Bouygues Telecom, some regions controlled by SFR. Each operator install the radio equipment only in his area. And this equipment connected to the two big bonds, SFR and Bouygues Telecom. And each subscriber routed, the communication routed or in the core network of Bouygues Telecom or in the core of SFR. But we need to communicate between two cores and each core with two mobile networks. And problem which addressing we should use. Public, it's expensive because we need near 4 or 5 class B of IPv4 public addresses. Private, always the risk of the conflict between two addressing of two operators. Of course, they are logical to use IPv6 to communicate between, but it's not possible at this moment because the radio equipment not well support IPv6 for the communication on radio network protocols level. Overlay for the subscriber, no problem, but not in the direct interface between equipment. We work with different constructors, Ericsson, Huawei, Nokia, Cisco, to deploy the solution, to deploy the underlay IPv6, because it's important for the next step to going to IPv6 only. Second subject, it's deployment of SRv6 and network slicing. Currently, in all our primary backbone aggregation access network, we use SR MPLS. And here a very important part, because for the MPLS before with the LDP, it was complicated because LDPv6 not well deployed, used, and when they pass to SR MPLS, we could use IPv6 like next hop for the routing, native routing of IPv6 traffic. And SRv6 permit to use more efficiently traffic engineering, programming with path with SDN, provide the cost, quality of service, and service level aggregation specific for the clients, for the enterprise client. And it's permit to deploy the network slicing, split network on the logical level between the different customers. It's very important from our point of view, next step for the evolution of the operator networks. Currently, we made the research to eventually mutualization between fixed and mobile network. Because as shown on the slide, we have globally the same network on access, aggregation, and backbone levels. Why do not aggregate on the function level? But here it's complicated. Each aggregation network had the broadband gateway on the point of attachment of aggregation network to the backbone. But for mobile traffic, need to route this traffic to the to the mobile data center. It's a different flexibility for the routing of the customer traffic, but there is different solution we are during to analyze. But it's not the finished. We could say we provide users with the ability to communicate using IPv6, okay. But really, we have a poor understanding of the new capability we can provide for IPv6 users. Because we're copying the IPv4 mindset. It's a big problem, really, because for the many users, we just replace IPv4 with IPv6, but it's not. We have new functionality for the subscriber, new technology, and it will change internet globally, because no NAT, globally no problem with MTU, probably using of multi-homing roaming for the subscribers, even public subscribers. who could use the CPE connected to a landline, fixed line FTTH, and use 4G or 5G mobile for the backup or balancing. But today, in this case, we have, even if you connect by two technologies to the same operator, you have two different delegated prefixes. Which delegated prefixes you should use for the line configuration? It's not clear. How it should change it if you lose a primary line? It's many questions, and today technical solution exists, but question which solution should be deployed and use it in the subscriber local area network behind the CPE. Internet of Things, okay, we understand what's that, but how it should change network and point of view operator for the provisioning of the subscribers. No NAT, it's mean the big push for the deployment of the peer-to-peer network. How it must change the configuration of the subscriber. We have many questions we needed to understand before go to the next step. Okay. Thank you.
Thank you, Viktor. Any questions?
Hello, I'm from DHL, and I would like to ask you your opinion about DHCP-v6 PD, since you are from the mobile, mobile company.
Behind the terminal equipment?
From usage of DHCP-v6 PD, what's your opinion? And I'm asking because I had seen in slide number 7, for cell phones, you are using, or you want to use DHCP-v6 PD. You have the array/array and DHCP-v6.
Okay.
For mobile subscribers.
Yeah.
So I think you are talking about DHCP-v6 PD, right?
Here, for this part, for the behind the terminal.
Yeah, exactly.
Here, there's a curious situation. For the, if we get the public equipment, smartphone based on iPhone, Apple iPhone, you could use. But Android don't support DHCP-v6.
They are PD. I'm asking about your opinion of DHCP-v6 PD. We will be talking today about that. But since your company is using IPv6 for much longer time than others, I would like to know your opinion. You have much more experience.
I've seen many use cases, and the big difference for the choose of the technology for the public clients, public subscribers, and enterprise subscribers. For the public, we decided it's not needed because just 0.001% of subscribers need something more complicated than the solicitation route advertisement. For enterprise clients, it's probably the smartphone with custom firmware, custom functionality, and for them, I have the DHCP prefix delegation.
Okay, thank you. So just to summarize, the rollout of DHCP-v6 PD on Android isn't changing your view to how you're allocating to clients on the mobile?
On the provider part, it's not changed. Probably we will look about the change the size of the allocated network for each subscriber. But problem here, primary problem, it's not a part behind the terminal equipment. Problem for the mobile architecture, very complicated to communicate the same, keep the same delegated prefix for each subscriber. It's important. It's important for functionality, for eventual aggregation with a fixed network. It's probably it's a heritage of our experience development of the network during many years. For new operators, they could deploy the topology which permit to avoid this problem, this difference for the fixed and the mobile topology. But it's a, I could say it's a classical topology, the classical problem we have seen at different operators. They are the same problem.
Thank you. Thank you very much, Viktor.